Okay, so for my constant rate for the modeling task, I'm using the heart rhythm of a person, kind of the heart rate, heart rhythm. So for this one, it would be the average heart rate is between, hang on, the average heart rate is, resting heart rate is between 50 and 70 beats per minute. BPM is what we're going with, beats per minute. So for this one, we're going to say y is equal to 60 because apparently that's the average heart rate for like a well-trained athlete. So 60. So, and then our x is probably going to be time because that's the most common constant factor. So for this situation, right? Let's say like you're a doctor or something, or like you're in nursing school. So like in this situation, no matter what you do, no matter how much time passes, that rhythm, that was a really bad line. Where's a tool? Ha. So let's go ahead and do this. So that's a thick line. Okay. Maybe a little bit thinner. Okay. So, like, let me create a little graph here. Wow. Let's stretch it out real far. Okay. So, for example, right? Let's see, we said our y was going to be 60. So, when we do an example like this is minutes, and this is BPM. That was very much not B. This is BPM. Okay, so in this situation, right, like this can be 10, this can be 20, this can be 30, this can be 40, and this one can be 50. Oh, that's a 60. Okay, ignore I'm writing with a mouse. It's fine though, you guys. This one can be 60. Okay, see, so as you can see, we have a full hour here, right, in minutes. If this person's heart rate, we're gonna do 50, 60, 70, 80, which, I mean, your heart rate can get to 80, it's probably not a resting heart rate, so move you down. Haha. Okay, so obviously, like, this is a full hour, this bottom line right here, this is a full hour of time in minutes. If your heart rhythm is at 60, that is never going to change unless you are going into cardiac arrest. Which, if this, like, I'm gonna use red. If this is for whatever reason spiking like this, like, I shouldn't say your heart rhythm. If your heart rate goes from like 70 all the way up to 80 and then all the way down to 50, you're probably dead. You're probably dying. But when your regular heart rate on a day-to-day basis remains at the same rhythm, so no matter what you do, or I guess it doesn't matter what you do, yeah, no matter what you do, your heart rhythm is always going to remain the same. It's not going to change unless you are, like, yeah. So, like, when you sleep throughout the night, like, let's say it's like 3 in the morning, right? 3 a.m., right? That's 60. This is going to remain constant because you are resting, you are sleeping, you are snoozing. You are, there you go, you're snoozing, right? That is never going to change because you're snoozing, you're resting, you know? Like, it's not going to change. So for domain and range in this situation, x is time, as I stated. Our domain and range in this situation are very constant, honestly. Like, no matter how much time passes for x, so let's say 10, 20, 30, bam, like, it's always gonna end in 60, because unless you are dying, which I hope you're not, it's not gonna change. If your heart rhythm is fluctuating, it's very much dying. So no matter what, it's always gonna lead to each other, you know? Arrows. Make it look cool, you know? Yeah, so no matter what, your heart rhythm's always going to stay the same. So what are like some limitations here? I'm trying to write. I can't spell for my life, you guys. Okay, what are some limitations here? Death. That's a very big limitation. If your heart rate's going like anywhere from 0 to 100 in like 20 minutes, it's first of all, your heart should never be at 0. Second of all, this is bad. There we go. First of all, your heart should never be at 0. Second of all, 100 is a very high heart rhythm, I guess you should say. But I mean, it's not impossible, but it's very unlikely. And if it goes from 0 to 100, or like 72 to 100 in a matter of seconds, it's probably not good. Secondly, right? So like, that's our first limitation here, right? Because like obviously your heart rate isn't changing. What's another limitation? Another limitation is like if there's something wrong with your heart, right? Like, say someone has heart issues and it goes in their family, like it means like bad heart issues, like that's going to cause a rapidly changing heart rhythm, which is going to obviously eventually result in death. But if you get it fixed, right, obviously this is no longer, the 60 is no longer going to be a constant, because like I said, you're getting it fixed, so it goes from irregular to regular. But it was still irregular to begin with. So, yeah. Those are really all the limitations I can think about. And I guess if you get like electrocuted, that could mess with it, but I don't know 100% about that. So yeah, so in this situation we have our y equals 60, our x is minutes, our domain and range, like this is our domain. This right here is domain. Try and write this with my mouse. And this, we'll do purple for this one, because purple's a pretty color, you guys. And this is our range, right? So, as you can imagine, like, this is our domain and range. These are limiting factors from. Here's what our graph would look like if we ignore the red. Let me just casually. Bam. Oop, that was the wrong button. That opened my Xbox. Do not ask me why it opened my Xbox, but it did. And now we paint everything white again. Haha. See, no more red lines. Paint purple, paint white. No more purple lines. Okay. Anyways, but yeah. So as you can see from this very poorly made graph, yeah. No matter, like, this is your constant. Y equals 60 is your constant, no matter what. So that's fun.